Jai Shri Ram, friends. Chapter Electrical Charges and Fields, Lecture 11. Today's topic is Electric Field of Dipole. Let us start. Now, today's topic is Electric Field at an equatorial point of dipole. See this diagram in which there is a dipole at point A and B. Okay, this is dipole setup. At any point P, which is nothing but equatorial point, you have to calculate the field. So, simply for the point on the equatorial plane, due to charges plus q and minus q, electric field of the dipole at a large distance, that is given by E, which is at equatorial point, is 1 upon 4 pi epsilon naught p upon r cube, and in vector form this is minus 1 upon 4 pi epsilon naught p upon r cube in the direction p cap, as you can see from this diagram. Okay, the dimensions are mentioned over here. Now, how to derive this expression? So again, I am drawing this diagram. Okay, you can see there are different components of field. Means this is equatorial field. It is having two components, as you can see, due to plus q and due to minus q. Okay, so there are two different fields. So E due to positive charge is 1 upon 4 pi epsilon naught q upon r square plus a square, as per the definition of electric field. Similarly, for minus q, this field is 1 upon 4 pi epsilon naught q upon r square plus a square along PA, as you can see clearly from this diagram. Magnitudes of E plus q and E minus q are equal, obviously, because this is equatorial triangle. So E minus q is equal to E plus q. Now further, components of E minus q and E plus q normal to dipole axis will cancel out because both are equal and opposite to each other with reference to this figure. So if we are further elaborating this figure, you can easily see that E at equatorial point is nothing but minus of E of minus q cos theta plus E plus q cos theta in the direction of P curve. It is very clear from this diagram. You can see this. So E equatorial point is nothing but minus of E minus q cos theta plus E plus q cos theta in the direction P cap. Fine. So you just put the values and you are getting E equatorial is equal to minus of 2 E of minus q cos theta in the direction P cap, क्योंकि E minus q is equal to E plus q. So, and further, if you refer to this diagram, cos theta is equal to A upon under root r square plus a square. So, putting the value of cos theta in this expression, we are simplifying and we are getting E equatorial, that is minus 1 upon 4 epsilon naught p upon r square plus a square की power 3 by 2 in the direction p cap. For short dipole means if r is very small as compared to a, so E is equal to minus of 1.4 pi epsilon naught p upon r cube in the direction p cap. So here E equatorial is opposite to p cap. Now, comparison of electric fields of short dipole in both the cases. Axial we have already discussed on last term, and right now we have discussed about E due to equatorial point. So these are the expressions. You can easily see from these expressions that E at axial point is twice the E at equatorial point. So this is an important conclusion. Now next topic is electric field due to charge ring on the axis. So this diagram is shown clearly. In this there is a charge ring and this is the center O, axial length, there is a point P. So this is a diagram which shows the arrangement of the charge. Suppose this is length dl, so E is equal to 1 upon 4 pi epsilon naught qx upon x square plus a square की power 3 by 2, and for x very much greater than a, where x is nothing but the distance of this point from the center of this ring. Okay, and E is equal to 1 upon 4 pi epsilon naught q upon x square. So this is an approximation. Now how to derive this expression? So this is very easy, as you can analyze this diagram. Okay, as per Pythagoras theorem, you can find out this r, which is under root I x square plus a square, where x is the distance, theta is the angle, as you can see from this diagram, and a is nothing but the radius of this ring. Okay, suppose that the ring is placed with its plane perpendicular to the x-axis, as shown in the figure. Consider a small element dl of the ring, like this. As the total charge q is uniformly distributed, the charge dq on the element dl is nothing but dq is equal to q upon 2 pi a dl, where a is the radius of this charge ring. Okay, now the magnitude of the field D produced by dl at point P is nothing but k times dq upon r square. Okay, as per the definition of electric field. So further becomes k times q upon 2 pi a dl upon r square, putting the value of dq as I've just discussed. So D has two components, de sin theta, which is perpendicular component, will cancel out. Only d cos theta, that is axial component, is here. Okay, so resultant electric field at point P becomes E is equal to integral 0 to 2 pi a d cos theta. Okay, because this is closed loop integral for the entire ring, this is the line integral. So 0 to 2 pi a, that is circumference of this ring, which is equal to 0 to 2 pi a integral k cube upon 2 pi a dl upon r square into cos theta. Now further, if you are solving this, cos theta is equal to x upon r. So E is equal to integral 0 to 2 pi m k cube upon 2 pi a dl upon r square into x upon r. Putting the value cos theta, we are getting, and I am simplifying this k q x upon 2 pi a into 1 upon r cube इंटीग्रल 0 to 2 पाई है dl, क्योंकि कांस्टेंट क्वांटिटीज हमने ये जो है इंटीग्रल के बाहर लेनी है. इफ यू आर सॉल्विंग दिस एंड cutting the proper terms, suppose this 2 pi a will cancel out each other and r square is equal to x square plus a square, we have already seen. So E becomes k times qx upon x square plus a square की power 3/2. Now further, if you are solving this, so E becomes 1 upon 4 pi epsilon naught qx upon x square plus a square की power 3/2. So this is an expression. Now if x is very much greater than a, तो p is quite far, मतलब p इस पॉइंट से बहुत दूर है. उस केस में e की वैल्यू हो जाएगी 1 upon 4 pi epsilon naught q upon x square. So this is the final expression. So friends, this is the video for today and I hope you got this video. Okay, so in next video we shall discuss about another points. Till then, Jai Shri Ram.